Hello, what I've got set up here is a Panasonic M10 VHS camcorder. It's recording just now, and as you can see the picture from the camera is quite good. However, if I rewind it and play back what I've just recorded, then you'll see that in fact all is not well. Right, you can see that there's no colour, and from the audio there's only a buzzing noise. I think I can just about make out some sound underneath that buzzing, I think. Now when you have a fault like this, it's a good idea to try playing back a non-good recording, as well as playing the recording you just made on a non-good machine. So to that end, I've got a tape with a test card on it, and I'll play that now. Another thing you can notice is that the pitch of the buzzing noise changes depending on what the camera's doing. If I press play, the motors start up, it increases, and then it drops back down, and then it increased again then as it started up. So that suggests that its frequency is dependent on maybe the amount of current being drawn from the power supply, so that might be originating in the power supply, that fault, that buzzing noise. I'm playing back that test card tape, and I can't remember whether there's a tone accompanying this or not, but what you can see is that there is in fact some colour, but it's not very good. Now I've zoomed into the coloured part of the picture, and you can see the colour's quite erratic. It's not stable, it's flickering and disappearing in parts of the picture. If I stop it, the camera picture comes back and the colour on that's fine, as you can see. So we've got a chroma fault in the VTR section of the camcorder. Hello, what I've got set up here is a Panasonic M10 VHS camcorder. I've now brought in a non-good video recorder to play back the footage I've just taken on the camcorder. As you can see, we've got the flickering colour we had when playing back the good recording on the camcorder. We've also got the buzzing noise, but we can hear the actual audio a lot better too. And the point of this exercise is to determine whether the fault's affecting record, playback or both. We can see it's affecting both. We can see that the colour's been recorded badly, but when played back on a good machine we do get something. But when played back on the camcorder, with the fault affecting playback on top of that, it's got to the point where it just can't be recovered. It's the same situation with the audio. And because we've got faults in multiple sections of the camcorder, the first thing that leads me to suspect is the power supply. I'll certainly look there first, as it's good practice to verify the supplies, or you can end up going round in circles looking for non-existent faults in other circuits. We're now looking at part of the schematic for the VTR, luminance and chrominance section. The chroma circuitry is contained almost entirely within this chip, IC8001, with just a few external support components. This chip is powered with 5 volts here from this SW 5 volt rail. There's also the playback 5 volts that's used at a couple of pins here and here. That's coming through that transistor, so it's being inverted. It seems to be all 5 volts. These are coming from the sub-video circuit. This is the audio circuit. The rails here come directly from the power supply. There's regulated 5 volts which comes in and goes off to the audio interface circuit and to the hi-fi circuit. There's regulated 9 volts which is the supply for the circuitry on here, and that also goes off to the audio interface circuit. And the audio interface circuit, this seems to be concerned with the audio from the microphones. The 5 volt comes in here and provides supply for the built-in microphone and the external microphone DC socket. It also goes over here to this mute circuit that's controlled by this VEE and AEE which I think is video and audio EE, and that looks like it's to mute the audio in playback mode, the audio from the mic. Now this is a hi-fi audio circuit. This one, where the other circuits for the audio seem to be using the 5 volts mainly for just switching circuits, this one does actually use it as a supply to this chip here. There's also a little regulator here, it's 8.3 volts, that supplies this chip. But I don't think that the fault's in the hi-fi, I think it's in the audio in general. So we've got the Chroma on the 5 volts and the audio mainly on the 9 volts. When I first saw that the audio was using the 9 volt rail, I thought that doesn't make sense. In these Panasonic camcorders, the 9 volt rail is one of the supplies for the sensor. And when it becomes noisy, you get that noise appearing in the camera picture. I've seen this on models such as the M10. And this is using the same power supply arrangement used across most of these Panasonic VHS camcorders. However, it's not exactly the same. This is the main 9 volt rail. It goes to the system control, the audio, the servo, the sub video, and in the M7 and a lot of the other camcorders also goes to the camera. However, in this model we also have it tapped off here before this inductor, where it comes down here and to this circuit, this pass transistor, looks like a little regulator circuit. It's filtered by this 220 microfarad capacitor and goes to the camera. I think this additional bit of circuitry is the reason why we're not seeing noise on the camera picture. We'll find out when we get the scope on it. The 5 volt going to the Chroma, it also comes in and goes to this Luma circuitry here. Now, there's no obvious visible problems with that, so we'll have to see. There might be a problem in the Chroma circuitry itself. But anyway, I'll open the camcorder up and we'll have a look at the supplies and see where we get with that. And going back to this power supply circuit, it's this 9V rail that we want to check first. If this is noisy, it's these capacitors C1015, C1018 and C1019 that are going to be at fault. They're all 220 microfarad 10 volts. In earlier models there's only 2 capacitors on this rail, but they do go, so there's a good chance that they have done here. This part of the board's the power supply. This circular component's the transformer for the circuit that generates the 16 and -8V rails. And this bit of shielding I think is covering the chip that contains the oscillator. So I expect to find at least one of those capacitors around here. I'll start by checking the 9V rail and then the 5V rail that goes to the audio circuit and the YC circuit. So this is C1015, that's the 9V rail before that inductor. It looks like there's a bit of noise or ripple on there. Let me put this hook on my probe. What's that, about 40 millivolt, 40 odd millivolt there. Well, it's not a little bit, it's not loads. What frequency is it at? It's like 10 microseconds. That's 100 kilohertz, so that's outside a audible range. Could be better, but it's not like loads. That's not what's making that noise, because you won't be able to hear that. But I could change them capacitors though. And then let's see, C1018's here. This is it after that inductor. That's even less now. You know, what's that, like 10 millivolts? You see they're using these are them circuit protectors like what are in that that JVC video, and they're set like in that JVC one, they're not on the schematic. So that's the 9V rail. I'll have a look at the 5V now. That's on this transistor here, that's the emitter, and that's pretty clean. I mean, this is on 20 millivolts per division, this, so there's hardly anything there. You see a bit of stuff here, but I'm not sure if that actually might be noise from my phone. What it is. Yeah, you can see this. I think that's being picked up. So they both look alright as far as causing that noise goes. Right, I've been looking again at the signal path for the audio, and I think I was a bit quick to dismiss the hi-fi audio board. Now, on closer inspection I've noticed that this chip here, this is an audio mixer slash switcher, and all the different audio channels come through here before being fed out to wherever they're going. This chip is supplied from its own regulator here, so let's check that. It's a linear regulator, but if the incoming DC's noisy or got a lot of ripple on it, and this filtering, if that's not working, then you'll still get a noisy output. Right, so this is the test point for the output. I'll look at that. I've still got on 20 millivolts. Let me change it. Yeah, that's like 4 volts. Like some oscillation there. on each thing, on each bit of ripple. So yeah, that's definitely the culprit. Right, back on the schematic again, we've got this capacitor C4524 and this one C4584. It's 16 volt 68 microfarad and 10 volt 100 mic respectively. There's also this one here after the inductor. It doesn't say what that is on here. There's other ones dotted about, but I'll have a look at the state of the caps when I remove the board. Yeah, the capacitors are these little black Matsushita ones. If you open up an old camcorder and it's got these in, you quite often find that some of them have failed. Hopefully they've not leaked and damaged the board. This is C4524 and this one's C4584. I'll replace them two first. I'm not sure if I've got any 68 microfarad ones for that one. I might have to put in another 100, same as this. It should work alright though, I think. It's either that or 47, so I think 100 probably better going up. Not very good, that's all black. Melted board or something. You see that? It's like it's just turned to like carbon or something. I'll see if I can get it out. Getting it out without damaging the board. I think it might have leaked. Seems to be kind of melting now. That's got it, I think. Felt like that anyway. That positive one leads a bit shorter, it doesn't look as in as good nick as that other one. The other side of the board, like, yeah, see that ring round it where it's been. Clean it off. It's mostly sat on that big copper fill there, so it doesn't look like it's done any damage. They're kind of bubbling. Yeah, that one's got a bit of stuff coming out of it. I'll clean them up. Put these in tester and see what they're like. Right, so this is a 68 mic one first. Wait on these things because it won't fit in that in them slots. It leads too short. Let's see what it comes up with. 1239 nanofarad. ESR 10 ohms. Let's see again. Seems to be going down each time. It's like 1 microfarad, and this is that 100. No unknown or damaged part. That one's failed altogether. Right, I've got a couple of 16 volt 100 mic ones here. It just fits. just about. See if it'll solder properly to that dodgy one. I think it's taking. That's them replaced. I'm wondering about other capacitors on board now. What sort of condition they're in. Another 16 volt ones here. I don't really want to like just go through and replace all capacitors. I'll put it back on and see how it is. I mark these capacitors with a marker. I know they're ones that I've changed. This is C4501. That's that one that the value weren't marked. It's 100 microfarad 10 volt. So I'll try this one as well. I'll replace this one and test it. That one looks alright. I'll put that one back in because there's no wrong with it at all. I'll put the board back in now and check that rail again. Right, so this is that voltage rail now that them capacitors have been replaced. And you see that's pretty much noise free. Turn it up to 20 millivolts. Yeah. That's much better than what it were. I'll try using the camcorder and see what it's like. Right, this is the camcorder connected to the TV. And straight away you can hear that buzzing sound's gone. Well, you can't hear anything. I'm recording this so I can play it back and see what the sound's like on playback. Hopefully it'll be better now. So I'll play it back now and have a listen. This is the camcorder connected to the TV, and straight away you can hear that buzzing sound's gone. Well, you can't hear anything. I'm recording this so I can play it back and see that's on what it sounds like on playback. That's mix. So I'll play it back now. This is normal. Have a listen. That mix sounds a bit dodgy. I think there might be a bit of a phase problem, but other than that, it sounds good. You see that the black and white picture's still a problem, so we'll look into that now anyway. Right, back to the service manual, and we're looking again at the Chroma chip and sounding circuitry. There's two supply inputs to this, which are here on pin 36. That's filtered by this inductor and these two capacitors, one of which C8028 is a 150 microfarad 6 volt electrolytic. The other one's at pin 9, filtered again by an LC filter, and this one's a 100 microfarad 6 volt cap. These are the first things to check. That power supply 5 volt rail looked pretty clean at the supply, so I'm expecting the same thing here, but we'll still check it before anything else. This is a supply input to pin 36. I'm going to check first. As I'm checking it at C28, which is here. There does seem to be some noise on there. Some sort of regular pulse on that line. Sure what that is or how where it's getting in. Well, that's like 0.2 volts. That could conceivably be messing with it maybe. have a look at the other one, C25. That's earth thing. That looks much cleaner. Right. Well, try replacing that first, and then I suppose we could record again and make another test. This board's on a sort of hinged connector. So one of these things that poke through, I forget what they call them. I'll turn it off before I start messing about with it. And then this is like a hinged connector. You just have to kind of squeeze that in. It pushes through all. A bit awkward. That's it, there we are. And that hinges back. Have to sort of take that off, I suppose, for now. 8028. It's here. Don't know how well this is going to show up, but I can sort of see it's got a kind of greasiness on the bottom of it. You see that? I'll get that test in that component tester. Put the component tester on. See what it comes up with. Take a long time. No unknown or damaged part. Now I thought I had some 150 microfarad caps, but I don't seem to be able to find them, so it's going to have to be a 220, but that'll be fine. Get the board clean first. Make sure it closes. Yeah. I'll check that rail again. So this is that input now, replace that capacitor. And you can see that's nice and clean now. While I'm on this board, I'll just check the supplies to the luminance chip. This is coming from the same source as the supply to the Chroma chip, and it's being filtered by L3002 and C3002. So I'll check that. And there's also this playback 5 volts, and that's being filtered by L3001 and C3001. That goes to a few places, so I'll check that as well. Okay, so C3001 first. Yeah, that looks reasonably clean, I think. Oops, one off it. Yeah, it's not too bad. C3002. That's earth. That looks like it might have a bit of noise on it. Yeah. What's that about? What, 50 millivolts, 45, 50 millivolts? Yeah, about 50 millivolts of noise on there. So I think that probably wants changing. That's falling out. That one doesn't look as bad. Doesn't look as bad as that other one, but it doesn't look fantastic. I'll give it a test. Yeah. Unknown or damaged part. We'll replace that. Right, now that I've replaced those capacitors, I'll do a test. Okay, I've got that test card tape playing again, and as you can see, changing that capacitor has solved the colour problem. It's actually producing a very nice picture. I'll make a recording as well so that I can make sure the colour's being recorded properly. I'm making a recording now and I'll play it back and check that the Chroma circuitry is fully working. I've not got the microphone attached, so there'll be no sound on it, but we've already tested that anyway, so we just need to check the colour recording. I'm playing back that recording now. You can see colour's good, it's nice and stable. That problem's gone. Right, that's it working again. You could replace other capacitors as preventive maintenance, and I probably will do that at some point. But as far as this video is concerned, we've located and rectified the faults and the camcorder's working properly again. So I'm going to put it back together and I'll record a bit of test footage with it and put that at the end of the video so you can see what it looks like. Well, that's it for this video, other than to leave you with a bit of test footage so you can see what the camcorder's actually like. Hopefully the video might be helpful if anyone's got an M10 that they're trying to fix. Thanks again for watching, and I'll say ta-ra. Ta-ra.